Picture an absolutely still, tranquil body of water. The surface is, just like glass. And then, without any warning at all, the water just ignites. A fire literally dancing right on top of the waves. It sounds like a magic trick, right? Or maybe some crazy optical illusion. But no, it's pure documented science. We're looking at a genuine scientific mystery here. How does water, a substance that literally exists to extinguish fires, suddenly burst into flames? Let's explore the science behind this incredible phenomenon. Imagine a lake, and suddenly flames appear on its surface. But what is actually burning? That is exactly the question we're setting out to answer today. To solve this mystery, we kind of have to play the role of scientific detectives. Because the truth is, things aren't always what they seem on the surface, and what looks like burning water is actually this incredibly complex geological and biological process hiding just out of sight. Okay, let's dive into this. The absolute first thing we need to firmly establish here is that water itself does not normally burn. It literally isn't chemically capable of fueling a fire. Instead, the water is just acting as a medium, like a conduit for the true culprit. And that culprit? It's methane, a type of natural gas. Methane is a hydrocarbon-rich fluid, and unlike the water it travels through, it is highly combustible. So when we see a lake catching fire, we aren't actually watching the water burn. We're watching methane gas burn as it breaks through the surface and hits the air. So where does this methane actually originate? If the water isn't burning, where on earth is all this highly combustible methane coming from? Well, to figure that out, we have to travel deep underground, down into the dark depths. And the origin story of these underwater gas seeps is honestly fascinating. It's a bit like a giant puzzle that starts with a cycle of life and death. First, marine life dies and sinks down to the bottom, right? Where it gets buried in the sediment. Down there in the dark, this organic matter slowly starts to decompose. But it's not alone. Tiny single-celled organisms get to work. These are chemosynthetic microbes, basically bacteria that convert chemicals from this decaying matter into energy so they can grow. And as a byproduct of this whole process, they slowly burp out and build up massive amounts of methane gas. Over time, this biological breakdown creates immense gas pressure trapped right beneath the floor of the lake or the ocean. Let's look at the evidence with a couple of real-world scientific case studies, Lake Kivu and Mono Lake. Now, what's really interesting about this slide is how it contrasts the unique origins of the gas in these two completely different lakes. In Lake Kivu, which is an African rift lake, the methane is mostly formed by bacteria reacting with deep volcanic gases. It's a highly specific, intense chemical environment. But if we jump over to Mono Lake in California, the gas sources are quite different. Most of the natural gas seeps there actually originate from ancient buried organic deposits that mix with heat from hydrothermal hot springs. So you've got two completely different lakes with two completely different geological recipes, but they're both producing vast amounts of methane. And when I say vast, the scale of this gas production is just staggering. Take a look at this number, 50. That represents 50 cubic kilometers. According to Geological Survey data, Lake Kivu holds approximately 50 cubic kilometers of methane gas trapped in its deep water. Just try to visualize that volume for a second. It's an absolutely mind-boggling reservoir of highly combustible fuel, just sitting quietly down in the dark depths. Then we have 160. At Mono Lake, scientists who were actively measuring the flux of these natural gases observed flow rates as high as 160 moles of methane per day escaping from just the natural gas seeps. That is a continuous, actively measurable stream of fuel venting right out of the lake bed. Okay, so how does it make its journey to the surface? With all this gas being produced and stored underground, it has to follow a very distinct sequence to put on that fiery show at the top. First, the decomposing matter and bacterial activity cause the methane gas to build immense pressure beneath the sediment. Eventually, well, that pressure has to go somewhere, right? So the gas escapes through cracks and fissures in the seafloor or lake bed. Once it's finally freed, it rises rapidly through the water column as distinct bubble streams. In fact, advanced sonar mapping has detected thousands of these bubble streams off the US coast alone. Now here is where the real magic happens. Once the bubble breaches the surface, the hydrocarbon gas mixes with the oxygen in the air. If that highly combustible mixture is exposed to an ignition source, maybe a spark, a dropped match, or even lightning, it can instantly catch fire. And that is exactly why a lake appears to burn. Which brings us to a major scientific twist, the unsung heroes. Why aren't all lakes burning? If methane generation is so incredibly common, and we know there are literally thousands of these seeps actively bubbling worldwide, why isn't every body of water on Earth a constant fire hazard? Well, the answer lies in microscopic ecosystems, and intense physical forces acting as a sort of natural defense system. First, we have these tiny architects of life, our unsung heroes, fluffy mats of methane-eating microbes. These little organisms actually consume the methane gas for energy, literally feeding on it before it ever has a chance to reach the surface. Secondly, in deeper waters, the immense physical pressure and freezing cold temperatures trap the methane in a stable, ice-like state known as methane hydrate. So long as the depths stay cold and pressurized, those greenhouse gases remain safely locked away in solid form on the seafloor. So the crucial point is this: these invisible underwater ecosystems matter immensely. Without these methane-consuming microbes doing their job in the dark, massive quantities of this potent greenhouse gas would constantly escape through the water and just pour into our atmosphere. They aren't just preventing lakes from catching fire, they're keeping this greenhouse gas locked safely in the seafloor, providing an absolutely crucial service for the climate and the health of our entire planet. And this brilliantly illustrates the reality behind the illusion. When we see a body of water seemingly ablaze, we now know exactly what is happening scientifically. As we wrap up our explainer today, I want you to remember this: the lake isn't burning. The invisible gas rising from beneath it is. Which really makes you wonder, what other powerful invisible forces are hiding right beneath our feet?